This is Physics 2211 Lab 5. It is about Slinky job. The purpose of the experiment is to model the motion of a stretched Slinky drop from static equilibrium and compare the observed data to a predicted model. We need to use knowledge of Newton's second law and other physics principles to estimate the Slinky's position at different times. We need to use the formula of Newton's second law. So there are two different situations. At the first situation, the net force is equal to the gravitational force plus the tension force. And at the second situation, the net force is equal to the gravity force plus the drag force. So the gravitational force is equal to minus mg, and the force of tension, we assume the magnitude of the tension force is equal to the magnitude of gravitational force when the Slinky is at rest. And the drag force is equal to minus k times v squared. So through the observations, we know that the Slinky's mass is equal to 1.75 kilograms. The stretched Slinky length is equal to 1.22 meters, and the initial position is given on the slide, and we assume the initial velocity is 0, and the total time period for the Slinky to drop is 9.12 seconds. So then, we use the tracker to track the motion of the Slinky's drop, and we get the y position over time diagram and the data. So for the globe script code, we set the mass of the Slinky equal to 0.175, and we added the initial condition for the position and velocity of the Slinky, and we set the acceleration due to gravity equal to 9.8, and we set the directional vector for positive y-axis. So there are two while loops here. So for the first while loop, it is before 6.20 seconds. It is because that we found out the Slinky's bottom remains the same position until 6.20 seconds. So before that, we set the net force equal to the gravity force plus the tension force. And then we have the velocity and position update formula, and then we plot out the data and print out the data. And the second time interval is between 6.21 seconds to the end. The only difference between the first while loop and the second while loop is that we set the net force equal to the gravity force plus the drag force in the second while loop. So this is the result. And when we plot the observed data and predict data on the same diagram, we found that the bottom of the Slinky remains at a constant y position until the top pushes down. So while the bottom is stationary, the force of gravity and force of tension have equal magnitude, and therefore result in a net force of 0. And once the bottom begins to move, both the force of drag and gravity are present. And for the discrepancies between the observed data and predict data, there may be some additional forces not counted in. So yeah, that explains the discrepancy. Thank you for watching.